Okay, so today we're going to be talking about graphing of rational equations. So that was the test that we just took today, was rational equations, but we're now going to graph those. So last class period we talked about how to graph x, 2s, 3s, 4s, 5s, 6s, and so forth, and you're still kind of working on those, but we're going to go ahead and introduce rationals to you. So we're just going to jump in and get started. These do work a lot different than the ones that we did the other day. So they're actually, I think, somewhat a little bit easier, as long as you kind of remember the pattern and the rules. So the first thing that we're going to do is we're going to talk about, remember when we solved these type of equations, we always had to state what our excluded values were. And so in this case, we know that x cannot equal 0 on there, or it would be undefined. And so when we're graphing, that becomes a very important part of our graph. And it actually has a name. It's called an asymptote. Okay? And the asymptote is this line that our graph gets closer and closer to but never crosses. Okay? So it is a line that the graph gets closer to but never crosses. And when we graph it, sometimes it almost looks like it crosses, okay? But you've got to realize it's just getting closer and closer and closer and closer. So in this case, our excluded value actually becomes our asymptote line. So in this case, it is x equals 0. Okay, so when we say it's excluded, we say it's x cannot be 0, but it becomes our x equals 0 asymptote line. And so we're going to go ahead, and what we do is we graph that in. Now when we graph that in, guys, we always graph our asymptote as a dotted line. Okay, because it's really not part of our graph. It's kind of like when we did our axis of symmetry, we would dot it because it's really not part of our graph per se. And so our x equals 0 line is our y-axis. So since it's on my y-axis, I'm going to make it a little bit darker than what we normally would. Okay, so what that means is my graph is going to get closer and closer to this, but not cross. Now, the easiest thing to do with your rationals is to kind of just look at some points. And so we're going to do that. So we're going to put in some points into our equation. So if I go to my equation and I'm just going to start across at 1, okay, and I put in a 1, that would give me 1 over 1, which is just 1. And so my point is going to be at 1, 1. And then we're going to put in a 2. So 1 over 2 is 1/2. I guess I don't need an equal sign there. And so again, I'm just going to graph these as I go. So I'm at 2, 1/2. Okay, and then I'm going to put in a 3. Okay. So that would be, 3 would be a third. These become a little bit harder to estimate. 4 would be a fourth. Okay, and whoops, and so forth. So we're going to keep getting closer and closer to that line there. So you can see that in this case, it looks like we're getting closer and closer to the y equals. Now I could put in, just to show you that in fact, this is our asymptote line going across this way. So we actually have 2. You can have more than 2. You can have 3, 4, 5 asymptote lines. But for the ones we do, usually we only have 2 to 3. So example, what I'm saying on that is if I put in, let's say the number 100. I'm just going to shoot way up there. Okay. If I put that in, it would still be at 1/100th. And you see how I say you really wouldn't be able to tell it wasn't crossing that line. Okay, and if I went back the other direction now, because that's telling me what it's doing on down here on this piece of it. Okay, so I know it's coming in here. And yes, there's a chance yours is going to look like it crosses. I understand that, but just as long as you don't make it cross. Okay, so the question now becomes what's happening over on the other. We did say it's going to get close to that and not cross. We could put in some points. So again, I could put in 1/2. Well, 1 over 1/2. Again, if I multiply by the reciprocal, that is actually just 2. So at 1/2, I'm up here at 2. Okay, so you do see how that's coming. So you don't need to put in a lot of points, but I'm just going to come in here. So it is a curve on there. Technically, it is not straight at any point. It is curving all the time. So remember that it is curving continuously. So now let's look over on the other side, on the negative side. So what we're looking at, again, are quadrants. Remember, this is 1, quadrant 2, quadrant 3, and quadrant 4. So the question is, okay, well, what quadrant is it going to be in, the other part of it? And so I'm going to just continue on with my t-table. I'm going to come over here and do me another one. Okay, so let's put in some negatives. So if I put in a -1, well, it would just be a -1. So -1 right there. If I put in a -2, I'm in a -1/2. Okay. And as soon as I start going, well, I know it's in this quadrant here. And it's really the reflection. In this case, this graph is the reflection of the other one. But it's just going to come in here. And again, it's kind of like that x3s and whoops, I didn't mean that to be so jumpy there. Let me see if I can make it just a little bit better. So curve it. Whoops. Well, this iPad right now. There we go. Something like that. So there's what your graph's going to look like. That is the graph, and that's all you need to do for a y equals 1/x. Okay? So now we're going to take this and we're going to shift it. Okay? So I want you to think about what do you think it would look like if I took it and on my x, okay, I did x -2. Okay, what do you think that would do to my graph? Okay, and so let me I'm going to slide that on up. We can still see it. Maybe you can see it, but I'm going to slide that on up and get me another graph going here. Okay, now when I go to do my asymptote, okay, so in this case, it is x equals 2, right? Because I took x -2 equals 0. X cannot be 2, so that becomes my asymptote line. So when I go to graph that, I want to graph the x equals 2 line. So that is the line right here. Okay? Now, if you look at my graph, that should make sense because with what we know before in the past, remember with our vertex form, how it was always x minus h and k in our formula, then that minus was in the equation, minus moved it to the right. We're going to have the same thing. Now, did I mess with my y at all? Okay, did I do anything, add or subtract to my y? Hopefully your answer is no. So that asymptote is going to stay, okay? So we'll talk about some rules, but guys, if this value here is a constant, okay, a number, then your asymptote line for your what do I want to say, horizontal asymptote will be y equals 0. Okay, so in this case, it's x equals 2 and y equals 0. Okay, and I could do a t-table and put it in, but if you notice, I didn't change a lot of stuff. I just shifted it. And so really all I'm going to do then, and all I would expect you to do, is to know it's still going to sit at the 1, 1 and the 1, 1. And I'm just going to sketch that in. Let's see, maybe I just fibbed to you. I guess we should kind of check that because I'm thinking something else here. So we can, well, yeah, it's still going to work. I'll show you what I was saying because I said the 1, 1, but that's not really technically what it is. But what I'm saying is I'm going to go put in 1, 2, 3, okay, because 3 is over here, okay? And when I put in 3, okay, that gives me 1. So I'm at 3, 1. What I was saying 1, 1 is because technically in terms of my asymptote, it's over 1 and up 1, okay? I don't know if that made any sense, but you can put in there. So I'm relating it to this one here. It's going to look just like that. It's just shifted. And so this one again is going to be here. And maybe that explanation, it makes sense why I said the 1, 1. Okay. There we go. And again, I'm going to come in here with that. So I don't expect you to do a lot of points. Really, all we're doing is our asymptote lines. And once you kind of get the ideal of the curve, you can fit it in. Am I asking you to make that perfect? Obviously not. Look at mine there. But as long as you have it in the right quadrants and so forth. So while we're talking about that, then what would you think it would look like if I had it at x plus 2? Okay, and hopefully you know, okay, well, x cannot be a negative 2, so x equals a negative 2. We didn't move anything on the y, so I didn't shove it up or down, and so y is going to be at 0. Okay, so when I come over here again, get my line in, I'm not going to ask you to do a whole lot of stuff with this. I'm going to have you do x equals a negative 2. Whoops, what am I doing? X equals a negative 2. See, I shouldn't do these in the evening when I'm tired. And y equals 0. There we go. So again, I'm just going to come in with my graph. Again, remember what I said about the 1, 1 point. Okay, because I didn't change anything else. There it is. And you could check, whoops, that doesn't, looks like that's going to cross. But anyway, you get the gist. Whoops. Again, it's going to go through that point. And again, you could put that in because now we're looking at negative 1. So 1 over a negative 1 plus 2 would be 1 over 1. Whoops, 1 over 1, which is 1. So it would be at a negative 1, 1. Okay? That's all you've got to do, guys. We could talk about x-intercepts and y-intercepts as we're doing this. Also, we don't talk a lot about the x and y-intercepts, but on some of these, we could definitely do that because remember that our x-intercept is where y equals 0. Well, that's if you set y equal to 0 on this problem, look what you got. Well, 0 times that would be 0 equals 1. That can't happen. So that's kind of like a no solution. There's our asymptote. Okay? But if I want to do my y-intercept, okay, remember that is where x is 0. So I could come in here and put a 0, okay, and that would be 1 over negative 2. So my y-intercept as at 0, 1/2. Well, look where that should have been if I'd have drawn it correctly. It would have been a 0, 1/2. Okay, so there's your y-intercept. So that part still works just like what we normally would. So let's go ahead and find our y-intercept here on this equation. Again, we're going to let x be 0. And so I would have y equals 1 over 0 plus 2, which is 1 over 2, 1/2. So this should cross at 0, 1/2. And again, mine is not perfect, but you see what I'm talking about. Okay? So you could also put that point in. It is possible that I would ask you for that. Matter of fact, I think on your worksheet I do ask you for that, if you can find it. Okay? So let's just go back through and sum up what we found. Okay, so if we have the basic equation y equals 1 over x, we know what it looks like. Okay, we have the two asymptotes. Okay, when I have y equals x minus 2, okay, I have simply moved it 2 to the right. That's all I did. And we can find our y-intercept. When I have y equals x plus 2, now it shifted it to the left. Okay? And again, it changed our asymptotes and our y-intercept. Okay? Now, what's going to move it up or down? And hopefully you know that if I move it with the y, so there, okay, I'm going to put it that way. So that should move it left or right. Because I'm putting now my number with my y. Now, here's the thing. Normally it's not written, though, in this form. Normally you will see it written in this form. Okay? So that's where it becomes very similar, guys, to our y equals a x minus h squared plus k. That our quadratic standard form. See how now we've made it look that way. So this, looking at it in this form, should move it, okay, to which way? Left or right? What do you think? Y minus 2. Taking my y values and minus and 2. So it should drop it down, up. Let's see. So we're going to just double check it here with the t-table. Okay, so I'm going to put in, well, let me go back. We can put in our asymptote. Let's go ahead and get that in real quick. Because we know x cannot equal 0. Let me put my pen in here. X, whoops, sorry, changing my colors. Our asymptote, I'll just write it down here. We know x cannot equal 0, so we know x equals 0 is our asymptote line. So in this case, like I said, we're talking about moving it left and right, or sorry, up and down. So my left and right asymptote goes back to what it was, okay? Because again, this is going to move it on the y-axis, up or down. Okay, so what we're looking for is what is our horizontal asymptote. What is it that y cannot be? So let's put some numbers in. Let's put in 0. Well, that won't work, right? Because we've got 1 over 0. So we've already said that down here. So we know that doesn't work. Let's put in 1 then. So 1 over 1 plus 2. So that's 3. So I am at 1, 3. 1, 2, 3. Okay? I'm going to put a 2 in. 1 over 2 plus 2 is 2.5. Okay, so I'm at 2, 2.5. Okay, now do you see which way it's moving it? Okay, hopefully just those 2 points you're going, oh, I see now it moved it up 2, which is, again, just like when we did our HK, that plus 2, remember, moved it up when we had it in this form. So my asymptote line is going to come right here. It's going to move it up. Okay, and again, that goes back to the formula. Think of it like slope y minus y equals x minus x. So that minus is in my formula. The 2 is the positive. It's just moved it up. So I'm going to come in. Get me a little graph there. Again, this one's my 1, 1 I talked about. There we go. Okay. Okay, I'm sure our video is getting a little long, so I'll stop with that. But just I'll leave you, that makes our y equal 2 as our asymptotes to finish that out. You could always, again, in this case, we're going to have an x-intercept. Look, we got one right here. So we're going to, if we're finding an x-intercept, we're going to let y equals 0. So you can tell by your graph what you're going to have. So if y is 0, I'm going to put it into that second equation. 0 equals 1 over x plus 2. I would minus 2 on both sides. 1 over x. You can cross multiply however you want to do that. Multiply by x on both sides. So I get a negative 2x equals 1. Divide that off. X equals negative 1/2. So negative 1/2, 0 should be my x-intercept. There it is, negative 1/2, 0. Okay, so let's highlight some of those points. There's my my x-intercept. Here's my asymptote. Again, there was my equation. So leave you with one final thought then. If I had y equals 1 over x minus 2, okay, this one was a plus, this one's minus, what should it do to your graph? So I didn't move it right or left. That means this stays my asymptote line. It is going to, again, do just the opposite of this one. So it should move it down too. And I should be able to sketch my graph in. So there's my 1, 1. There's my 1, 1. Do you see where I'm getting that? Woo! Whoa, that's funky. Okay, so I'm off on that one, but you get the idea. And you could go in and check and find your, let's see, what would we find here? We would find our x-intercept because it's right there. and check that point. So let y equal 0. Okay, and see what you get. And it looks like it should be a half. Okay, so leave you with that thought. I'm going to cut this one off. I know I got long.